Production and factory settings bring their own set of hurdles for wireless connections. Harsh conditions, both indoors and out, create a daunting task for engineers to work through. Now let me tell you, those engineers ain't looking to back down from a challenge like this, no sir. This here's where we gather round to tackle them hurdles, swap thoughts, and lend a hand. Welcome to the Industrial Wi-Fi Shop with your hosts, Scott and Jeremy.
Hello, everybody. It's that time once again. Another episode of the Industrial Wi-Fi Shop coming at you. Episode 22, Industrial Strength, Wireless Freedom. My name is Scott McNeil, and with me, as always, the co-hostess with the mostest, Jeremy Baker. Say hi, Jeremy.
Hey, Scott. Hello, everybody. I just wanted to tell everyone out there that Scott is the person that puts ho, ho, ho in hotspot.
That's fair. Real quick, our normal housekeeping stuff here. Wyco's schedule is kind of cleared out. I don't think there's going to be anything scheduled till after the new year. As soon as I see something come up, I will share it out with everybody. Coming up from the wireless universe, we have WLPC. That is in February in Phoenix, Arizona. This is the conference that started them all. If this were the Lord of the Rings, WLPC Phoenix would be the One Ring. It's February 17th through the 19th, and it does have boot camps, 14th through the 16th. So if you really want to get your learn on, head out to Phoenix. We'll supply links in the show notes. Speaking of WLPC, Jeremy did get his notification, and he will be speaking again this year at WLPC. Give us a little
Yep.
preview, a little sneak preview here, Jeremy.
Well, if you're a listener and you voted for it, thank you so much. So I put two talks up, and the one that got the most votes was basically an overview of common industrial wireless deployments. So I got 20 minutes to talk about that. So I got to figure out what the common and interesting ones are and get that started now. So I'm not last minute.
Well, that's going to be awesome because they record those and put those up too. So
Yep.
that'll be good to share out to everybody, and we'll be sure to share that on the site. Don't forget our document library with lots of free, valuable, downloadable content. We have conversion tables, we have IoT reference charts, and we're starting to build a nice collection of best practice papers for you in all facets and manners of industrial wireless related material. So good stuff. Check it out if you need something to kind of help you get your stuff going. Today, we are episode 22, Industrial Strength, Wireless Freedom. We're going to be talking with a longtime friend of ours, Josh Varghese, and we're going to be discussing everything that goes on behind the curtain, right? Wireless communication, contrary to popular belief, does require lots of wires. So
Boo.
in the, you know what, Josh, let's welcome Josh to the show. Josh, tell everybody a little bit about yourself real quick before I
Hey,
start
what's
going off on a tangent.
what's happening, guys? Well, y'all two know me, but for your listeners, I am the founder and lead consultant of Traceroute, and we are a OT networking focused consultancy. And we were talking earlier about how industrial OT networking seems like a niche within industrial automation, which is a niche itself, arguably. Lots of people, if you're not in this space, you don't even know that it exists. But I started in automation out of school, and then a few years in, kind of moved over to the networking side of things. And that's all. That's all we do is just build networks for industrial automation systems. I will say we don't do personally a ton of wireless deployments, but I spent almost 10 years at a disty that, on the line card, several vendors with wireless radio. So it's not to say we haven't been around a lot of wireless applications. And certainly on occasion, we get called to troubleshoot and stuff like that. I would say we don't design a lot of wireless systems, but we troubleshoot plenty. We've made plenty of product recommendations. And maybe outside of terrestrial wireless, we do have a lot of history with cellular systems as far as general category of wireless. But most of what we do is around design, configuration, procurement, troubleshooting, and a whole bunch of training around OT networking.
The very infrastructure that supports the wireless universes that Jeremy and I work in.
Yes, sir.
And
That's
Scott, we should definitely get a picture of his background wall because that thing is pretty sick.
It's totally fake.
It's a
it's
it's a
cabinets.
green screen. Yeah.
Yeah, it's one of those cabinets. You just open it up and there's stickers on the cabinet.
Sometimes people make me go grab something to like prove that the wall is real. I have to like pull a switch down and bring it to the camera.
Yeah, my
Well,
lab's not so well put together. Mine's just my big workbench over there. So
But that's the key, right? I remember when we first built a lab wall at my previous employer, we'd changed buildings and there was this big task to make this nice wall because it was right behind this like glass window through the main hallway. And I was like, well, time out. Is this a demo wall or is this a lab wall? Because those are not the same thing.
they are not the same.
I was
yeah,
like, if it's a,
if it's a demo wall, you got to
yeah.
get stack lights and stuff that just beeps constantly.
I was like, if this is a lab wall, it's never gonna be neat.
No, no, no. A lab should like your dirty bedroom as a teenager. There's
Yeah,
going to be
that's right.
stuff everywhere. But that's
We
how it
had
should
a
be, right?
we
I
had
think
a
so.
thing that was like 30 or 40 panels that all needed to be networked together. And I just remember coming into our lab one day and it was just like this big spaghetti monster stringing out because it was like
Ugh.
every cart you could find had a panel on it and they were all just, it was wild.
Yeah, it just looks like it throws up multicolored spaghetti, because you have cables of every color going everywhere.
Hmm.
When we finally converted this room, so Mike and I both work out of our houses, and when I finally converted this room into a quote unquote home office and decided to do this wall, part of it was genuinely practical as far as since we do work out of the home and we are like doing little mini fat tests and stuff like that on occasion. I had, a three additional 20 amp circuits pulled to the room so that there was four 20 amp circuits in here. And I remember we were looking at a job and I could just tell looking at the quantity of hardware, I was like, this is going to push it. I was like, Mike, let's spreadsheet it up and tell me where we're at. And it was like basically the maximum we could possibly support in this room. And I was like, if there's literally one more switch, this whole thing's got to go. This whole thing's got to go somewhere else.
I've popped the breaker here several times. I've had
I'm sure.
well, I mean, when they built the house, code was 15 amp breakers, and
Okay.
so I could safely put a 20 amp breaker in there and not worry about screwing up the wiring. But if I put too much else in here, I'm actually going to have to get new wiring put in and have a 30 amp breaker put in.
Yeah. Well, you work for an integrator. I've got some good integrator partners, fortunately, that aren't that far away that I've leaned on a few times already to be like, can we do this there? You guys are set up for this. I'm not trying to burn my house
Our
down.
our, our lab space at work is no joke. Our
Yeah, I
lab space
bet.
at work is we moved into a new building and it's pretty massive, and
Yeah.
it's got we're building full cabinets and everything there now. We've
Yeah.
grown so much, and
That's
it's
awesome.
pretty awesome. Steven and the guys do a bang up job on the cabinets, and then we have our data center right there, so we can go ahead and start labbing up client gear, getting it all configured as if so that way when it gets to site, it's plug and play. We've already done a full fat test and everything.
Hmm.
So before we even, get more lost in the weeds on everything we've already talking about, I just wanted to real quick run through some basic kind of OT network primer stuff for those who don't work in the OT space. Most wireless guys work in the traditional enterprise space, be it public sector with schools or hospitals or hospitality or general enterprise and whatnot, and you tend to run by your standard IT rules of the road, right? The basis of that is the CIA triad, right? It's confidentiality, available, or integrity and availability, right? CIA, and it's at the top of that pyramid is confidentiality, and that's because in the IT universe, security is king, right? All your data has to be secured. It all has to be locked down. Followed up by data integrity. Is that data complete? And finally, is that data available, right? So availability is your last notch on that chain there. It's your last piece. So it's not quite as important as everything else. So if you need to go reboot a switch or if you need to reboot an AP and someone's disconnected for 30, 45 seconds up to a minute or two, what's the worst that's going to happen? They don't get their cat videos or their email is paused for a few minutes. It's nothing too crazy, right? Or you're delayed on getting into a meeting. It's nothing that's going to be detrimental to the universe. But for the OT universe, we take that CIA triad and we rotate it. All right. Confidentiality is no longer top dog. Data availability is king. The data has to be available, right? Not only does it have to be available, it has to be complete. So our CIA triad is more of an AIC triad with availability at the top, and then you have integrity. So you have to have that data available. You have to have that data complete. It has to get from point A to point B. Otherwise, the process stops. If the process stops, that is bad. Then you're not doing what you're supposed to be doing. Now you can argue, well, yeah, you're just losing money. It's unplanned downtime. Well, depending on the process, if you're talking chemical processes or robot processes, that could also be a safety hazard, an issue, in which case that puts at risk not only the equipment, but in many cases and instances, human life. So the data has to be available, it has to be complete. And then if you get the chance to secure it, that would be great. But security is more of a bolt-on because if your data is not getting there and it's not complete, the security portion does not matter at all, right? Now, do we want it to be secure? Yeah, if we can, we want it to. But if it's going to disrupt that process, then no, it becomes a liability as opposed to an advantage. So that's really the mindset that you have to look at. And then what that does is that filters down to the rest of your networking philosophy, right? And that goes from hardwired and then into wireless. Now, at the wireless aspect, it's much easier to secure things because security has pretty much from day one been built into wireless devices. But on the networking side, when you're dealing with the OT universe, and you look at all of these controls devices and bots, many of these devices were not built with any sort of security in mind whatsoever because it adds process overhead, it adds latency, it adds all these other things that actually are a risk to production. So there's a lot of things you can't secure. So if you can't secure an individual device, then you have to secure the environment that it lives in. To take that one step further, so now we have this whole manufacturing, network kingdom, but we have to keep it separated from the IT universe kingdom because Sally from accounting does not need to have any sort of access to any of your devices down into the OT universe, right? Because Sally from accounting, she's clicking her cat videos, she clicks a wrong link, next thing you know, she's got malware and ransomware. That spreads relatively quickly. Next thing you know, all your machines are locking up and your entire factory shut down. And so, in which case, from an operational standpoint, well, your availability shot, your integrity shot, and well, security didn't matter at that point anyway. So now you've got to segment off your OT universe, and we follow our own set of rules down in OT. We use all the same equipment, in theory, different form factors, different shapes, different heat tolerances, but essentially it's the same thing. We use firewalls, we use routers, we use switches, we use various servers and whatnot, and we use a lot of wireless. And so, but the gear has to be built differently. In the grand scheme of things, as with enterprise, there's a lot of hardwired infrastructure that goes in to support wireless applications. And that's what we're talking about today is that difference and what has to be built and put together and what our differences are between OT and IT and how we then go forth and support the wireless applications. Did that make sense, or am I just starting to kind of run on ad nauseum now?
No, you're good. I was going to ask one question. You mentioned the CIA triad, which is the same thing I learned and taught for years. I was curious if in the last 5 to 8-ish, I've heard increasing buzz in like the ICS cyber community for the SRP triad. Have you heard that one?
I have not. Do tell.
So it's in this context of IT/OT convergence and the how OT prioritizes versus IT, and the SRP being safety, reliability, and productivity as being like the driving factors in OT and sort of the where the focus is and the attention is as far as criticality.
So you said that's the SRP?
Yeah, SRP, safety, reliability, productivity, and sort of, and I think the reason I don't remember the full history, but I think the primary reason for that different discussion was that first word, the safety word, that has um, a disproportionate amount of importance in those OT networks versus the IT networks, and the fact that it was somewhat missing from the conversation when we talk about priorities and what we're focusing on in those systems. I suspect that's where that whole we need even a new triad to discuss was to make safety paramount.
No, that makes perfect sense. I'm going to look that up specifically and get that put in the show notes. So let's kick off with our environmental differences and what that means to our equipment, right? Josh, like me, like Jeremy, you've got experience with a lot of different vendors' gear,
What?
from 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 Phoenix to Cisco to Moxa to all these different manufacturing brands, and there's a core difference between industrial hardware and your standard IT hardware. And a big part of that is DIN rail mounted gear, right? And
Yeah.
so DIN rail mounted gear is built typically for higher heat tolerances, typically built for higher dust and insulation tolerances as far as airflow and whatnot, because the vast majority of them are solid state. You don't put fans in an industrial switch. Forgot what
That's actually a good example to that point about the equipment being different. I was at a wastewater facility and we were there troubleshooting a wireless system, actually a Ubiquity system. And I saw a guy walking with a rack mount catalyst switch to this, like across the plant, heading into the centrifuge building. And I was like, I gotta know what this guy's up to. And so I follow him in there and I see him open a control cabinet. I was like, hey, what's going on? He's like, oh, we're just replacing the switch. You got to replace it every few months. And so he was taking a rack mount Cisco catalyst switch with fans and replacing one that had sucked in what is typically in a centrifuge building into the fans and overheated and died. And I was like, did you know that Cisco even, like if you're Cisco, I'm not trying to get you to change brands or anything. The same vendor, same software, everything you're used to, they make that switch in an industrial form factor that doesn't have fans that's meant to survive in this cabinet. He's like, what? And
And
that's
it's probably not much different in cost to the one you're putting in there.
yeah. Yeah, well, and especially if I think he was averaging like 6 switches a year in this panel.
Yeah.
He just had a
Wow.
stack that he was just like, all right, around every 2 months, this thing's gonna fail and we're gonna replace it. So I don't take for granted when we do trainings or I'm talking to people that are sort of outside of again this niche that like this assumption that they know that there's specialized hardware for it because nobody at this facility knew, and it was costing them a ton of money as a result. That like, oh, you
Yeah.
literally just need. They make, and it was funny to me because it was literally the same vendor, right? I'm like, I'm not even trying to get you to install something you won't understand. Once you plug this in and power it up and IP it, like you're gonna manage this the same way you were managing that rack mount, right? You're not gonna be able to tell the difference. The only difference is you don't got to drag your ass out here every 2 months to swap it out.
Well, and along with that different form factor also comes different power sources, right? Because these DIN rail mount switching, you don't just plug them into a 110 outlet. They're either depending on your needs, they're either 24, 48 volt power, or they're what is it, 54 volt? Is
Yeah.
that the next step up?
Yeah, I think we were typically for a long time used to just 24 if it was non-PoE or going to 48 if it was PoE. And then once those PoE standards started climbing, so did the VDC requirements on that power supply. So I've seen a lot asking for 52. I've seen some asking for 54. I feel like I've seen some asking for 57, 58 even. I don't know if we're in that what is it, PoE plus plus plus, this
Right.
like 90 to 100 watt range.
I just specced out a bunch of gear for an upcoming project, and the radios themselves require PoE plus. And
Okay.
so we were having to go with 54-volt switches, which changes the entire power dynamics of a cabinet.
Yeah. Yep.
For those who are not familiar with cabinets and whatnot, as far as in this context, when you're looking at an industrial cabinet that has all your controls and everything in there, typically they're wired for 24-volt DC power. That is by far the most common. That's not to say there's not others, but this is a prime example. They typically, your cabinet builder would typically pre-wire it and everything and set it up for with power supplies for 24-volt power. But when you have a couple of devices on there that need a lot more power, and PoE Plus is a prime example, just like we were talking about, now you're having to look to go to a 54-volt power supply, and that's a big power difference. So that
Also fair warning, for all of us who like to play in the lab. Like this lab wall behind me, over my right shoulder, it's 24-volt supplies all the way down the left side there. But there are some PoE switches at the top right of this thing, which I intentionally put up at the top right away from the rest, because there's a 54-volt supply over there. And what you don't want to do is take the output of that 54-volt supply and power a 24-volt switch, because in a lot of cases, that leads to you letting the smoke out, which we don't love to do.
No, because once you let the smoke out, you can't get it back in.
Well, I did that about 20 feet from where I'm sitting right now because I looked at the pinout and I was like, I didn't think about which way the pinout diagram was, and it was kind of a symmetrical connector. So I wired it to the wrong two wires on the adapter. I plugged it in and it went.
There's two types of people in this world: those who have let the smoke out, and liars.
Yeah.
Hey, I was on a project up in Virginia, and the electricians had some new people on their team, and we had just installed some very expensive static switching, and they have everything all wired up for me, and they're like, "Hey, you ready for us to power this on?" And I'm like, "Yeah, go ahead and do it." They do it, blue spark pops, kills the switch. And I was like, "Oh, that is not good." But hey, we got a spare. I go grab the spare. They pull the power tab out that's pre-wired and they put it in the new switch. They throw the power back on. Blue spark pop kills the second switch. They had miswired the power cap that you actually plug in. And so it just cost them, that mistake just cost them to the tune of almost 10 grand to replace both of those switches. Yeah, it was not fun. So then we had to go find an old switch that they were going to decommission, reconfigure, and then double check their power. They fixed their power, and we were able to get them up and running, but not optimally like we originally were planning because they fried the two brand new ones from miswiring.
Mm.
But fortunately, it was electricians doing it, not me, so they had to pay for it, not me.
Yeah. That's the powering of that stuff is definitely like an interesting problem because, before we got on the call, Josh was talking about, is a demo wall versus like a lab, like a
Oh
test
yeah.
wall. And it's stuff's in flux, but some of these things, the panel's beautiful when it's installed, all the wiring's neat, but then this thing fails and then they got, the form factor of a switch changes or they need to add ports or something like that. And then all of a sudden you shift stuff around and you got to reroute stuff a little bit. And it changes, it changes over time. And usually, the Panduit cover breaks or whatever, and then it starts getting messy. And I remember one time we had a thing, they blamed it. It was the wireless is the issue, right? And then we did all this troubleshooting on it. And then eventually they discovered, hey, we swapped the air conditioner on this crane out a couple months ago, and the grounding wire is they didn't route it and mount it properly. So it was sitting in the evaporator pan. So anytime that thing filled up with water, it'd brown out the power. And it was just enough, just enough that like the wireless interface stopped working properly. So yeah, I mean, that's definitely like, that is, OT problems.
Well, and with that form factor change, that also changes when, we're just talking about generic switching in general, it changes your port density. The higher that port density in an industrial switch, typically the dramatically more expensive they get when you look at an 8 port versus even a 20 port if you're willing to have the budget appetite to get one with that many. And a lot of times you're looking at a modular base switch. So you're actually buying a base model switch for 4 grand, and then you're getting a module that's almost as much just to increase your port density. I know that's the case with Cisco and Stratix in general. Now you look at Phoenix, I think the most I've seen with Phoenix contact switches is what, 16, 18 ports,
Yeah, think so. Around that
roughly.
range. Yeah.
Not sure about Moxa. What about Siemens on their switches, Jeremy?
Well, they've got, so it depends on what you get, right? Like I mean, they do have some, which you earlier you were saying there's not really like AC. So they do have some AC powered like rack mounted stuff. So when you want to be in the core, and they've got, kind of 24, I think they even have 48 ports, maybe even more. They've got some modular with cards and stuff. But even the DIN rail mountable stuff, they'll have like a 16 and you can add an additional card to it and get to 24.
Okay, so they have the modular switching as
Yeah,
well
so they
in
have
their
some of
DIN
that
rail
stuff.
stuff.
And then there's and the way kind of their switches work too is like they have, they have not, I don't want to say like lower level, but they have like lower, where it's like unmanaged layer two managed, and then they have some that are like layer three, or they're layer three capable with a license plug. And then like the 4000 series is all like their industrial router stuff. And then that stuff, if you have PoE or any of that kind of stuff, you can add additional cards onto it, and then you have to add a power supply, or you have to power that separately.
Oh, that's interesting.
And then
Yeah.
they also have the rugged comm line that's kind of like in their field for that too.
Well, then you move from switching, and when it comes to OT networks in general, segmentation is every bit as important in the OT network as it is in the IT universe. And so you're running a myriad of different VLANs, and you have your main OT network ideally segmented off with a firewall or a pair of firewalls in high availability. But when you get further down deep into the guts of the of the industrial network, there's a lot of cases where you need to individually firewall off other segments, and that leads to smaller DIN-rail specialized firewalls, right? I know most of what I've played with DIN-rail firewall wise, as far as deep down, are the Phoenix M-Guard series, which I'm a big fan of, and then actually Fortinet has a series of industrial firewalls that are essentially they're full blown, fully functional, every option they've got
NGFWs.
firewalls
Yeah.
just in an industrial form factor. And some of them have built-in wireless modules, some of them have built-in cellular modules. I mean, many times it's complete and total overkill, but by God, they can do it.
Yeah, that you have Siemens has a couple of those too. So they've got like the 615, which is kind of just like a standard one WAN port, four LAN port. They've got the same kind of, because they also have that Cinema RC, the remote connect, where it's got like the VPN connection stuff built into it. So you'll have those where it's like individual machines, and you can do like toggle on with a relay or text or any of that kind of stuff to allow the VPN connection to establish to go out for like individual machine cells. Yeah, so there's all kinds of them out there.
Yeah, it was maybe a month or two ago, somebody had reached out for an application, and they're basically trying to limit what could talk to this PLC like down at the panel level. And so we were talking about transparent bump and wire layer two, and it goes by several different names, but basically, yeah, DIN rail firewall, picture it with just only needing two ports, and we're just gonna take the cable that's going into the PLC, run it through this thing before it goes to the PLC. And I wrote this post to basically show all these pictures of, oh, it's crazy how much that space of the options have expanded in the last 15 years. And I showed pictures of a couple of Moxa options, a couple of Hirschman options, some Siemens options, some Dynix options, Fortinet, TX1, Phoenix, and that still wasn't comprehensive. But it was
Right.
literally like, oh, we can do this. I can supply 12 different boxes to solve this problem, and that's not even all of them.
Well, and then you take that down to wireless. We've opened the door to security there, then we talk about our wireless security, right? So typically with industrial APs, you have all your standard, if it's 802.11, you have all your standard security suites from depending on what version, like if it's a Wi-Fi 4, it's going to have your standard WPA, WPA2, up to all the latest where you have Wi-Fi 6, Wi-Fi 7 out there, along with all the associated security measures. But once you get back to your OT network, you have to make sure that the security measures you're taking there, number one, aren't interfering with data flow, but are still locking your system down, right? And that's kind of what all of these inline firewall devices are for. Now you bring up the transparent mode. I didn't even know a transparent mode was a thing until I got into the OT universe about 10 years ago. That whole
Mm-hmm.
transparent bump in a wire. I had heard something similar from Palo Alto that they had done that they called it I
Blue
forget what they
wires.
called it.
And Fortinet calls theirs virtual wire, I think, or
Oh,
that's one of the
V-Wire,
ways you
yeah.
can
So
do it.
that's
Yeah.
what I believe that's what Palo Alto was
Palo
calling
calls
it
it.
too. And that concept didn't quite hold with me until I got into the industrial universe, and then the whole concept made a whole lot more sense because I was playing with my first little M guard, and you either have that M guard in a router firewall mode or you have it in a transparent mode. And again, I didn't even know that was a thing. So that was a real eye opener for me on what you can do to control and segment and isolate systems while still allowing the proper amount of data to go through that needs to go through, but not having to readdress everything and not having to NAT everything, you know.
Well, and that flexibility, like I remember we had a large oil and gas customer that had developed a segmentation plan and a re-IP plan to go out to all these compressor stations and re-IP, but that's not going to happen overnight. And they wanted to improve their posture as quickly as possible. So one of the things we're able to do is like, yeah, if you can get one of these products, MGuard's a good example. We did it with a Hirschman Eagle at the time, where it's like this thing can run in either operating mode. So today you can go drop these in today without needing to re-IP immediately and write some rules about what can come through this thing. But then when the re-IP is complete, you can switch this thing into a routed firewall mode and continue to use that same hardware that you bought and spent money on, and leverage it kind of before, through, and after the re-IP. So it's kind of nice to get that flexibility because like there are such things out there that are like literally only transparent firewalls, like the Tofinos from back in the day, or there's a couple of products that's the only mode they operate in. But I sort of like the ones where they can be multi-personality like that, and you can sort of ride a customer through this journey in case they are eventually doing this re-IP anyway.
Yeah,
Yeah, so you get
I
you get
use
that like,
some. I'm
oh,
sorry, go
sorry,
ahead,
Scott.
Jeremy.
I was going to say you get that kind of like you can crawl, walk, run with them
Yes.
through it, right? And say, hey,
Yep.
this will shore it up a little bit now, but then
Yep.
you're not having to replace the product later on down the road.
Exactly.
Yeah, the context I had used the Phoenix and transparent mode was for some wireless I/O.
Hmm.
Was hiding some wireless I/O behind it, so they made sure that only the specific protocols were going through, and there was no re-IPing everything, and that
Hmm.
was pretty important to them at that point in time. So,
And speaking
um,
of, like, I have one that's wireless related too. I had made a video a few months ago where we got a call from the field where they had added some new drives, VFDs, and some I/O to a system. And part of this sort of sprawling system was a narrowband radio network out to like a dozen small PLC panels. And we're talking like maybe 2 to 400 kbps. I mean, it was slow enough to where they had to round robin the PLC polling of these remote stations. And it worked fine until they added this handful of new stuff onto the network. And they're like, ever since we've added these new devices, like we're just not getting consistent polling of these remote locations. And you know how the situation is sometimes you're getting phone call of a phone call of a phone call. I don't get packet captures or anything to see exactly what's going on. I was like, look, I think we can guess that master radio of this point to multi-point network is seeing stuff it wasn't seeing before. I don't know if we're occupying the airwaves or if we're locking up the radio, but one of the two things is happening, and it'd be good if we could limit what is coming to that radio. And so the point of that video is we were going through all the options of like, what are the things we can do to limit traffic to the radio? How quickly can we get it done? What does it mean in terms of deploying hardware? And so we're going through options, including ACLs in the radio themselves, deploying a transparent firewall, leveraging like private VLAN capability in a switch that was already out there so we could just make changes remotely. But it was all in this context about, yeah, limiting what's going to the wireless network. And in that case, it wasn't necessarily, again, security driven. It was just a pure operational robustness reason. Like this could not handle the additional traffic it was seeing. We need to shield this narrowband radio network from this new additional traffic.
Yeah, absolutely. Even blocking even even just blocking broadcast and multicast traffic can clear a lot of that up. But I mean, when you start talking about multicast, that's a whole nother rabbit hole that you can go down that can disrupt a lot of different things.
Well, I talk a lot about how both those categories, like broadcast traffic, like minimizing size of broadcast domains because OT devices, especially legacy ones, just can't tolerate a lot of extra stuff. And then yeah, I think you already know I talk ad nauseum about multicast leaks on networks, and I'm talking about them tipping over, wired OT devices, controllers, I/O drives, whatever. Well, now we're adding to the mix, we're talking about radios. And I think sometimes, depending on the vintage and the category, it definitely falls into that same thing of they're not trying to listen to all this extra noise. They don't, if it's not meant for them or meant for that network, what's it doing? It's just chewing up CPU cycles on a radio when it's trying to do its job. One thing I was curious, I've heard somebody say, and I wanted to hear from you too, if this is super common or if you've heard of it. I've also heard I'm saying these are problems on wired only networks, this extraneous traffic. And I had somebody tell me that certain radio brands and models, things like broadcast traffic, there's settings in them about your one broadcast may turn into they're going to repeat it 3 times or 4 times just because of the nature of the wireless network. Is that a thing you've come across and ever had to tune or mess with?
Well, I know with what I've worked with, typically, we will not allow broadcast to go across, and we'll change the settings that turns broadcast to unicast.
Okay.
And so I could conceivably see where you would end up with multiple unicasts if you're just getting
Hmm.
slammed with a lot of broadcasts, right?
Sure.
Same thing. And well, I'm not going to say same thing with multicast because a lot of times you just disable multicast on the wireless radios because that's a metric crap ton of extra traffic that's just eating up airtime.
Yeah.
Now, at home or in a corporate environment, you kind of need that multicast for a lot of video devices
Hmm.
because a lot of people now are using the little HDMI plug and play wireless
Oh
adapters
yeah.
for TV monitors and meeting rooms and things like this. Even what's the Google version that you can plug
Oh,
into
cast.
yeah, the Chromecast. Well,
Yeah.
I mean, that's all multicast. And so you have to enable multicast on your wireless systems in order for that to work. Well, that's not what you want to do down in the OT universe because you're just airtime is already at a premium in these spaces, and you want to keep your wireless latency as minimal as possible, even more so in the OT space versus the IT space. And so if you're allowing broadcast and multicast, you're just eating up a lot more of that airtime and you're creating a lot more airtime contention, which just is
Hmm.
increasing your latency. And as you well know, the more latency you have, the higher risk you have of tripping out a PLC or a control module because it's exceeding its refresh times, right? It misses its 3 or 4 heartbeats and then it says, "Oh, I'm stopping."
Yeah,
It's broken.
that's a good, I mean, that is a good use for like, call it a machine cell or whatever, right? But like that's a lot of like two of those little mini firewalls in there. It's like you might, the IO might only need to talk to a PLC, but sometimes that traffic will come back across the wireless and cause problems too. And it's just extra crap on there. And we're especially like in the AGV world, it's layer two retransmissions is a big problem. So and then, so we look at like latency and jitter and stuff like that. But I think another thing too that might be worth discussing a little bit is stuff like Josh, I don't know how often you find this, but like spanning tree is not really something that you want on a production system.
We do in our training, we do 5 to 10 minutes, probably 20 minutes on layer two redundancy in general and covering like different layer 2 redundancy options, particularly in industrial networking. And of that 20 minutes, a solid 5 is around spanning tree for a few reasons. One, me just letting them know in almost every managed switch platform I've ever worked with, like almost, I think everybody on this board, it's true. Yeah, I can't think of an exception. It's on by default on all these
Yeah.
platforms. And it's one of the biggest examples I give of a managed switch that you buy and don't manage doesn't behave the same way as a truly unmanaged switch. Spanning Tree is one of my big examples that like, no, it's doing things. It's running protocols and processes that your unmanaged switch isn't, that is leading to behavior that you've probably noticed and not understood what the cause of it was. And so we get into spanning tree and particularly to say it's on by default. And if no one has done any meaningful configuration of it, generally speaking, in most industrial networks, it's just kind of running wild. And what customers notice is, hey, when I plug in my laptop into this panel, my laptop won't communicate right away. I notice the lights are like blinking yellow and orange. And maybe I'll go get a cup of coffee and I'll come back and then it's blinking green. But they've also noticed that like operators are sitting there looking at a SCADA screen and it seems like a ghost of lack of communication or comm loss is like working its way through the system. And it's just this daisy chain spanning tree event that started with somebody plugging in a laptop or powering down a panel and powering it back on. And just spanning tree defaults and any of those situations means like, yeah, no ports are configured for port fast. So they're not gonna, it doesn't know the difference between basically what I call a threat. If a link comes up, that could be a link that's making a loop. So we're gonna treat it as a threat and inform all our neighbors. All our neighbors are gonna flush their cam tables and then relearn all their, it just leads to this constant domino event. So in my opinion, spanning trees just it was never really designed certainly with industrial networks in mind in general, but the bottom line is if no one's gonna like own it from an administration standpoint, it's generally more trouble than it's worth. I understand that we want to prevent loops. Most of my customers will either take that responsibility themselves as we own that if we make a loop, we'll take it down, or they'll leverage other options on the platform. Sometimes there are just standalone loop protection mechanisms on these managed switches, which that's all they're really trying to protect is the guy who opens the cabinet, sees a cable hanging down and goes, I guess this should be in here and plugs it right back in. So normally we'll make a lot of recommendations towards designing purpose-built redundancies, whether it's rings or rings of rings, sub rings, things like that, leveraging other protocols, whether it's MRP or REP or you name it. And we just try and get spanning tree down to as close to a zero as possible. What about you guys? Because I know that's not necessarily a consistent or prevalent opinion.
No, I try to I view spanning tree as a necessary evil in some instances. And typically when I have to deal with it, it's not down in the cabinets themselves. It's
Some
if you're looking at
interface
Purdue model, you're
to an
looking
existing
at like,
network.
layer 2.5, layer 3, in which case it's still typically left, unconfigured. And unconfigured
Yeah,
spanning tree is a problem,
yeah,
right? Because then you don't have any priorities set. So everybody's having to hold elections to see, first of all, who's going to be the boss, who's going to be your root bridge. And then they have to plan all their routing accordingly when you have just redundant links. And so I was at a site that I helped them do a complete OT redesign. And one of the problems they were having is, they knew that if they plugged in and created a loop, that it would take a minute or two, but then it would function, right? Because
hmm
default spanning tree was taking care of that. And they were like, hey, there's our redundancy. Sweet. The problem is then every time that they plugged in something, and some of their switching was configured by vendor A, some of their switching was configured by vendor B, some of their switching was configured by vendor C. Well, some of these vendors take spanning tree into account, some don't.
yeah,
So the next thing you know, they have a vendor who's installed some switching down in a cabinet and they have set spanning tree priorities. And all of a sudden, a whole nother election happens, and that industrial switch down in your cabinet that has 4 ports and one device hanging off it is now your root bridge and is master and commander of all your redundancy for everything across the network. And so they will, well, we're having an outage in this area. We're going to take down that one switch. And then it has a ripple effect across the entire network as well. Now a secondary, route has to go and elect itself. And all of a sudden they're causing a 10, 15-minute outage across the entire site because all they wanted to do was take down this one building while they did some work to its power systems or whatnot. So if you leave it all unconfigured, it does. It just presents like a madhouse of different things. And then it becomes, because they don't know what they don't know, then it becomes a pain in the ass to troubleshoot because you're trying to trace down all these different symptoms that they're telling you.
Yeah.
So there's a lot to be said about going in and at bare minimum, setting root bridges on primary switches, and then going through and say, hey, when you ever add a switch in this
Yeah.
area, you go
Give them an
ahead and you
SOP.
run this one command and you set up
Yeah.
a general priority for that switch. Because that's the beauty of industrial networks is they're very deterministic, right? And that's a big key thing here. Everybody is talking to somebody specifically. There's very little dynamic action going on in an industrial network. And if you see a lot of dynamic action going on, dynamic communication going on in industrial networks, then there's a problem. There's typically that's a security issue at that point, that something else is going on there. Once you've got that segmentation going off, and I mean that's what all these other security appliances do, right? Your Clarities, your Nozomis, and whatnot. And you put these in there, they require X amount of time to get their baseline, so they can understand what devices are supposed to be talking to other devices. Again, it's because of that deterministic nature, right? So when you start seeing that, this device down in one area is now trying to talk to 8 different devices and it's constantly changing, there's a problem, and it's able to flag that and tell you because they know that all of this should be deterministic.
Oh, you touched on spanning tree as far as defaults, another like thing that bites people and is annoying and they're blind to until they dig into it. But between vendors, the version, we're talking about rapid spanning tree protocol, multiple spanning tree protocol, per VLAN spanning tree protocol. There's all these flavors of spanning tree. And my favorite example for this is, let's go back one generation of Stratix, the 5400, 5700. I think that's what's out there in heavy volume right now, because that's what was getting deployed for close to a decade. Those switches, the Stratix version, and their OEM equivalent, the Cisco equivalent of those switches, if you had the Cisco in cabinet A and the Stratix in cabinet B, by default, they're running two different versions of spanning tree. The Stratix is running MSTP and the Cisco is running PVST. So even though those are both running Cisco iOS, were made around the same time, they literally look the same other than the color of the paint, those two are incompatible. You will have issues at the boundaries where they connect. And then the latest generation of Stratix 5800 and 5200 gets released. What was it, a year and a half ago, whatever. And we
A
were
year and a
doing our
half ago, yeah.
review of the series. Come to find out, they're not continuing to make MSTP their default like the previous generation of Stratix. So
No, it's
now,
rapid now, isn't it?
yeah, I think it's Rapid PVST
Yeah.
plus. So now, even between Stratix of different generations, you don't have the same default spanning tree version out of the box. I'm like, oh, this is okay. This is great. We just
Well, and
made
to
it
take
even
that a
harder on
step further, you're
everybody.
exactly right. Then you start looking at other vendors, and
Yeah,
other vendors may only be capable of one of those flavors.
sure. So
Um, you
it's
know,
just that, so the conversation we typically have with customers is like, if you want it, here's what you're going to need to do. And like you said, we're developing an SOP about like a bare minimum you need to do. You can't just drop in a new switch and walk away and treat it as unmanaged unless you want some unpredictable behavior. But my one note to you, like, I agree with you about the traffic, the static nature of the traffic. But what I'll qualify here in terms of our spanning tree recommendations is like, we just, for whatever reason, happen to work with a lot of customers that are in heavy growth phase where their networks do not look the same day to day in terms of adding a new switch, adding devices. They're just constantly adding stuff. And so their ability to keep up with something like that just depends on how well they're staffed. We know that that varies facility by facility. We have some that can absolutely keep up with it. Some that we know that's an undue burden. That there's adding that one more thing for this automation engineer to do is maybe just a stroke too far. So we go this other direction where I mentioned where Worst case, what we're trying to do, almost like the VLAN thing and the broadcast domain thing, is we're trying to minimize the size of a single spanning tree domain. I don't want some issue in a cabinet on the first floor to affect a conveyor belt operating on the east side of the building on the fourth floor. So we'll do something like rep to like chain throughout the building and then have little spanning tree domains hanging off of the main like plant facility wide, rep chain or something like that. So at least one incident is sort of limited in scope or blast radius from a spanning tree perspective.
Well, I tell you, I'm a huge fan in general of ring topologies. I do work a lot with Cisco equipment, and so rep has become my friend, and you can rep over ether channels, so you can get redundancy and with resiliency, and you can increase throughput needs where you need to and whatnot, and it just makes for very clean installation,
Yep,
right? And it keeps that deterministic nature in place, and it's well, the big thing too is failover convergence time is so much faster on a ring topology versus your standard scattered spanning tree topology. So
for sure. Yeah, um we had a customer once, it was going to be around 60 Stratix switches. The system had like 1,500 VFDs on it, 200 PLCs.
wow.
Each Stratix had 3 DLR rings with 30 to 50 devices each. So we're talking like 180 DLR rings at the facility. But when they first laid out the drawing, I was like, oh, what's the redundant? Like you could tell there was redundant paths the way they were showing like how this was connected at a high level. I was like, oh, what's the like configuration plan for redundancy here? They're like, I think they're saying just let Spanning Tree do its thing. I was like, I don't think you want to do that. They're like, what do you mean? I was like, well, do you have a requirement, like what you would tolerate if there's an event? How much time could you tolerate before you're like stopping belts or whatever? And in typical end user fashion, they're not giving me a number. I was like, all right, how about this? I don't need all 60. Let me set up just 8 of the switches, just a subset on the bench, and we're gonna cable up a mini version of this plan, and I'm gonna show you what you can expect. And so we were literally like recovering times and pulling cables and recording times and showing them like, okay, yeah, here's a 300 millisecond out. They're like, okay, I don't love it, but maybe that's okay. I was like, now watch this. And I did a root bridge failure, and they had a 7 second outage during this root bridge failure. And they're like, yo, we can't do that. I was like, that 7 is with 8 switches. This number is going to get a lot worse at 60. He's like,
You can
okay,
come
well,
back. Yeah, you can come back tomorrow.
yeah. He's like, okay, what should we do? So we changed it to like a rep topology and then redid the experiment with the 8 switches to show him with rep that like, okay, look, we have sub 50 millisecond convergence. By the way, you only have an issue on the break. When I repair it, you don't have a second incident like you did in the spanning tree situation. And also, we're doing multiple rep segments here, and a failure in rep segment 1 has no impact on segments 2 through 15, whatever. They're like, oh yeah, this seems much more robust. I was like, all right, cool, let's go for it. But it's these situations where you almost have to, they're not going to give you the numbers because they don't know the numbers, but they know what they don't like. So I have to
Right.
demonstrate. Let me show you something I think you're going to hate. And that's why we don't want to go down this path.
Yeah, it's gonna work great. Hey, watch this. What do you think about that? So maybe this might be a good time, while we're talking about ring topologies, to just kind of give like a high level of kind of how those function. And I know, so MRP is like a industry standard, and then rep is kind of the Cisco flavor. Siemens has one that's HRP, but they all essentially, you connect all of your devices around. So there's an in and out in a ring, right? Every device is connected to one other device all the way back around. And so typically, and correct me if I'm wrong on this, right, is that you'll have one port that is your communication port. So the traffic goes out end to end, and then the other port gets logically closed. And a lot of times what they'll do is they'll still monitor traffic on there, and occasionally they'll send a test packet out that will go in the reverse direction of the ring. And so then on your forwarding port, if it receives that, then everything's good. And then if it misses that packet a certain amount of
Yeah.
times, then it knows that there's a physical or a logical break in the ring at some point. So then that
Activate the
blocked port
standby.
then becomes logically open and becomes forwarding. So now you have bidirectional traffic from there until it's restored.
No, you nailed it. That's pretty much every rep I work with the most, and that's exactly how rep does it.
Yeah.
Yeah, these all like I think a
Resilient
lot of
Ethernet
these
protocol.
there was so many vendor proprietary, like Hirschman had HyperRing and Moxa had Turbo Ring and Garrettcom had S Ring and Entron had N Ring. Everybody had this proprietary ring topology and they were like on this race to the bottom of like how fast they can converge. It was 500 milliseconds, 200 milliseconds, 50 milliseconds, 30 milliseconds, 20 milliseconds, DLRs, 3 milliseconds. But in general, they all operate under that exact same principle. You have one ring manager. That ring manager is sending test packets in both directions to basically monitor the status of the ring. And when I tell customers about rings over like an open spanning tree, we literally show the state table diagram out of the RSTP spec. It's so complicated. And I'm like, yeah, this is the thing. There's a lot of, I think there's so many different port roles in spanning tree that you can take and there's all these different things to the decision tree about what to do because spanning tree can do not just rings, it can do full meshes. So I get it. Do we need a full, like very few customers, I've never had a customer looking to build a full mesh. They just want to know that if a forklift takes out one of the cables through the plant, that
Not
that
if,
one cable
when.
down or that yeah, when, or when that SFP fails, because that's also a when, when that SFP fails, that single point of failure doesn't cost them $100,000 an hour while they're even chasing down what failed, let alone how long is it going to take to fix it.
Hey,
That's
Josh,
another
do you,
good. Go ahead.
I was gonna say, do you mess around with like DCSs much at all?
We get called into like paper mills and certain verticals that obviously run DCSs, and
Because
so
that's another
yeah.
kind of layer of it is
Oh
like,
yeah.
I know in the Siemens stuff, they have HSR that they typically do with that. And so then that's almost like running a PRP, where you have a parallel, but what it does is it sends traffic out of
A frames
both.
and B frames. Yeah.
Yeah, but it just has like it's the exact same traffic the whole way around, and
Yeah.
everything has, an in and an out from your A and your B. But
Well,
all that
some of
stuff
the
is, it's like closed loops.
Yeah, we
some of
just
the
did our
stuff you have to
first
be careful because, like with ABB, just as an example, they require two segmented separate networks, and then the software
Mhm.
on their devices handles the redundancy. You have an A network and a B network. That's their redundancy, and they just need to be isolated from one another.
yeah.
And then everything's dual homed on those A network and B network, and all your individual end devices are what actually controls the redundancy. So to me, it's kind of a weird concept. To a controls guy, it makes perfect sense. But yeah, it's crazy.
We so at a paper mill there was a Honeywell DCS system, but at this plant they obviously like they have the DCS system for a certain portion of the mill, but then they have this general plant network with a lot of miscellaneous automation, including some GE PLCs and some additional software packages, and they need the two to communicate. There's some bits they're passing back and forth between these two systems, and at this interface between the quote unquote plant network and the DCS network, by default there was no redundancy, and that bit them more than once, and so they asked like, can we connect these in a redundant fashion? And they have admin access to the Cisco switches supporting the Honeywell network, and I had admin access to the Hirschman switches supporting the plant network, and I was like, I can make a redundant interface between these systems, but I already know what's going to happen. Honeywell's going to come out here on some sort of audit, and they're going to be like, no. And so they're like, no, that's fine. We want to do it. So we do it, we test it, we demonstrate it to them. And then 6 months later, they're like, yeah, they came out, they pulled it out, they reverted the configs on the Cisco. They said it's not compliant. I was like, cool. Do you think we can get on a call with them to find out? Like, they keep saying compliant to the standard. Like, what is the standard? Is there something we can do that would be compliant? No answer. Customer's like, will you come do it again? I'm like, what? You want me to reset it up? You're going to pay me to come do this again? They're like, yes. We go out there. We ended up doing this 3 or 4 times where Honeywell would come out on their annual thing and basically revert, rip it out. Customer kept paying me, and I was like, all we need to do is get them to communicate, show us this document. And over the course of whatever that was, 24 months or something, I never got Honeywell to produce a document that I like to at least let me even understand what not compliant to the standard meant. And I think it's because in general, they're not designed to interface to another system, right? It's
Were
a
you
standalone
using were
DCS.
you using like link aggregation or something like that. So if one of them drops down,
But
In
port
that
channeling.
case, let's see, it was between like a pair of Hirschmans and a pair of Cisco's, and they didn't have stacking Cisco's. So no, we were probably leveraging something like two switch coupling on the Hirschman side to come into
that's
these.
that might be what I was thinking. Not
But bottom line is like, we're obviously touching like port configurations on the Cisco's to put things into the right VLAN and everything.
Mhm.
And they're just doing audits against it. Here's what the config was last time we were out here. And if it's different, it's reverting. Like,
Well, that's, for them, it's like it's a checkbox, and because then it's almost like they're looking at it like, well, if you have a problem with this, you're going to expect us to
that's
support it,
right. Yep.
and this is the modular template that works. Here you go. It's plugged in.
Yeah, it was one of those situations where like no amount of conversations could prevail in terms of Mr. Customer wants to do something to improve their uptime and reliability, and they're talking to a brick wall in their supplier as far as like not interested in having this conversation.
Well, we've done, Scott. I don't know how much you've done with this, but we've actually, in a ton of high availability things, had a lot of growing pains, but a run like using like a red box and then doing parallel, like parallel wireless links to things. So then you got your A and your B, but but then it's like even, okay, I'm not going to name any vendors, but vendor A has this much of a buffer that they can have in
Mhm.
that A and B packet set, and this other one has more, and you'll overrun it. Then you get the out of series packets, and that causes a bunch of problems because it's not intended to go over wireless from the physical box. But I mean, it's always interesting because customers want all the redundancy they can get in the world, and then you tell them, well, all you got to do is buy a completely separate
Second
network
set of hardware.
infrastructure, and then they're
Yeah.
like, oh good. I will not get that approved.
I specifically, I got a client design using some ProSoft radios that I imagine we'll get the PO here for soon, and it's just going to be a short point to point, but it's the redundant systems. So network A and network B need to be able to go across this bridge, and so we're actually doing two separate wireless bridges. Um, and so I'll have them on a different channel scheme, different security, whole nine yards. Um, but it's going to be able to take both of them across this, I don't know, maybe quarter mile link because they're adding a new building into their OT network, and they have the same control system in the new building as they do in the old, so they want to keep it all in the same control structure. So,
Hey, Jeremy, you mentioned AGVs a few times. I was curious. So I think it was just last week or the week before. You'll probably both know Killian from Siemens.
Hmm.
He had posted a doc about the transparent mode in the radios. Basically, the example of you've got AGVs, and so you've got a lot of duplicate hardware, right, from a IO and a local controller trying to talk in the plant to a master controller. And generally speaking, you would just want to maintain the same IP scheme in every AGV and do the
Yeah.
NAT thing. But the problem is, which is fine for like the UDP communication from the AGV to some server, but there's a second requirement of the master controller talking to all the AGV controllers, which requires PNIO, like Profinet IO layer 2 comms, which you
Hmm.
can't NAT. And so they had this like application note about this kind of specialty feature in their radio to kind of concurrently facilitate NAT for the overlapping IP devices, but then you could specify device names that you wanted to expose for PNIO layer 2. I was going over that document with them and saying, okay, I love what you're pitching here. This document, I think we need some clarification because it's missing some detail that would help me understand the configuration a little bit more. But I was wondering, have you done that application before?
We have not done that yet, because so
Okay.
typically, like, with a lot of our customers, it's typically right, like it's not necessarily like, hey, here's a Siemens infrastructure or something like that where they're necessarily passing IO across it. It's
Okay.
more a lot of them are more like, okay, we've got like a fleet manager, and you gotta pick this thing up at point A, and it's basically like a big ASRS warehouse
Okay.
type thing. And then a lot of the like the dark rider, like the entertainment stuff, there is like IO and interlocks and all that stuff that are on there, but those are not necessarily typically Siemens as we interface with them. I mean, there are some
Okay.
out there, so that's not something that we've done yet.
Yeah, I was
But
just
most of
curious because it's one of these cases where, this whole discussion of like, is Ethernet, and does it matter what protocol? Like, if it's a Siemens thing or a Rockwell thing, and like
Mhm.
wireless is again yet another spot where it gets even harder because you can take something as simple as what seems like a automation device behind a client radio, and all of a sudden it works wired, but it doesn't work behind the client radio, even though the client
Yeah,
radio
because
is a bridged connection.
yeah,
And I'm
the
like,
whole
what's happening
passive
now?
client thing.
Yeah.
Yeah, so that's, I mean, and that's usually like the kind of common fix of that is like IP masquerading, NATP, and then everything like only the vehicle controller is needing to talk out over it. So you want to block that stuff off.
The other one I wanted to ask y'all about was it was a few months ago. So when we were talking about power earlier, and we were talking about going up to, 48, 52, 54, maybe even higher, 57 volts for the power supplies to the PoE switches to support the wireless infrastructure. And I came across something that surprised me a couple of months ago, and I was wondering, have you guys already seen this? Were you guys already aware of this? I would say up until a year or two ago, I never thought too much about having a PoE switch connected to non-PoE devices. I would say we've had it a million times before and never thought twice about it. We're counting on PoE to do its thing, to negotiate, see that I'm not being, advertised a class of device, so I'm not going to put power on this line towards a device. In the last couple of months, I feel like this has blown up on me a little bit. And so I'm going to ask this a few different ways. Question number one, have you ever connected a PoE switch to any sort of device? Not a passive PoE power supply, just an industrial PoE switch. Have you ever connected it to something and watched that thing let the smoke out?
Yes.
Do you remember what it was?
It was uh the PoE switch, the power to the PoE switch was experiencing not not a brownout condition, but a slight overcharge condition. And it was on a stacker reclaimer boom arm that every time uh, the uh, uh, the stacker fired up and all the electricity surged through this entire giant machine to power everything up. Apparently, the power lines were I don't know I don't know, it was just a weird situation, and it was like the slight overcharge, or it could have been a brownout. I don't know. It could have been a drop, but it was very weird. It was that power condition that would then, if there was a non-PoE device plugged into a switch, it would get a charge from the PoE switch. And it conceivably, on one note, it was a smaller little sensor that was plugged into it that was battery powered. It just needed an Ethernet connection. It fried those little sensors.
So in your case, we're talking about potentially a fringe anomalous power condition.
Correct.
So you haven't had everything seems fine, but you just plugged something in and the device smoked.
I have not, no.
So I shared a link in the chat, you guys can look at later. A customer of mine ran into this. He plugged in a 1783 NATR, the Rockwell NAT appliance,
Okay.
into a unmanaged PoE switch, and the NATR smoked. And then we went on this couple of month journey of trying a bunch of different unmanaged PoE switches and checking like what we could replicate. And then he ended up in a conversation with Rockwell. It's all in this article that he wrote. And Rockwell has like a QA guide. Like they published a guide about a list of 17 product families that should not be connected to PSE equipment. And the NATR wasn't even on that list. So presumably that list isn't comprehensive, but it has to do with a couple of things, including like the design of the power sourcing equipment circuit. There's a couple of ways like low side switching versus high side switching. And then also the way the end device, like how its Ethernet port is literally set up as well. But bottom line that I'm flagging here is there are known manufacturer published saying we know don't just plug a PoE cable into this device, which I had never considered as potentially being problematic before. But now we have the vendor straight up acknowledging, like, yeah, don't plug a cable from a PoE switch into this thing. And by the way, we've also it doesn't even necessarily matter if you go out of your way to PoE disable that port. You're still not necessarily safe. And the follow up to this
Really? Even if
was
you disable all PoE function on that port, it still. Well, then what's to keep a normal switch from frying that very same thing?
well, so the follow up to this was a couple of months ago. We were trying to test some of those new Fortinet rugged switches,
Uh-huh.
and we were just trying to build a MRP ring between three of the new models on native copper ports on the switch, and it wasn't going. We get on calls with them, and then they flag us to a few things in the quick start guide, and there was three bullets in them, and one of them was like, so we were talking about the 216F. This is the big monster. Is it on the wall right now? Not on the wall right now. It's their latest big monster industrial PoE switch. The quick start guide says like we do not support connecting two of these together over copper ports. Don't do it. Like if you want to connect two of these together, use the SFP ports. And if you want to do it over copper, get some copper SFPs. So they directed us to some DACs to buy, but there wasn't much qualification of the statement. They were just like, just don't do it. I'm like, okay, cool. But then the second bullet in the guide says, disable PoE on a port before connecting the cable of a non-powered device to a PoE port. But even if you do that, that device better not use the same DC negative as the DC negative feeding the switch power supply, which, as we were talking about earlier, depending on your power supply setup and your wiring in your cabinet, I would argue it's real easy for that to happen and you not to think twice about it. So here's another scenario where we're maybe smoking devices if we're not paying attention to this quick start guide. And then the third one basically says, like, it says any device connected to this switch requires proper safety isolation and voltage withstand as the switch may provide power even if the connected device is not a PoE powered device. So it's basically saying there are scenarios in which, and that's what we were testing, me and my customer were testing, even with those unmanaged switches too. We were noticing that there's 54 volts on the pins, even when we haven't detected like a quote unquote PoE circuit, that there's a load there calling for PoE supply. So there's this whole category between like the Rockwell publication, the unmanaged switch supplies, which are doing low side switching instead of high side switching, which I don't know if it was common or not, but it did seem like there was something in common about like the country of origin of the ones that did it one way versus the other. But I don't have it comprehensively enough to say it. But there's just this whole category of concern I didn't have for a decade of standard PoE and PoE plus. I feel like it's only come about with every time this has come up, it's come up in these higher PoE categories. Those unmanaged PoE switches were PoE plus or maybe plus plus. This Fortinet switch I'm talking about is also PoE plus plus capable. I haven't been able to like pinpoint like what changed. What happened to we're only going to provide power if there's a device that's meeting a PoE class that's calling for powers, but something changed somewhere along the line to where I can't make this assumption anymore, and we've got to be a lot more careful. And that's the reason I'm bringing it up, is because I feel
So
like it's
so
something for y'all
moral
to
of
dig
that
into.
story is pay attention to your wireless devices that are PoE and your other devices that are either PoE or non-PoE when using switching that is PoE plus plus compatible or higher
That's what we've seen
because
so far. Yeah, like whereas before, because
wow,
I don't think you would have hesitated before.
I
Like
wouldn't
let's,
until we've had this conversation, I
yeah,
never would have hesitated to plug up
exactly. A
no.
non, yeah, yeah. Like we're powering an AP on port one, and you're taking port two to a IO to a drive. I wouldn't have thought twice about it. And now I'm like, I guess we gotta tell customers not so fast. Let's look
Well,
at what this
I,
particular power sourcing equipment says.
I think that you've uncovered a product that we need to have developed, a PoE condom, right? Like the I know
The
that's
isolators.
kind of goofy sounding, right? But like kind of like a reverse of like the data, those little data
Diode.
things where you can strip the ability to transmit data across a charge
Yeah.
cable so you can plug it into a strange place. Maybe something that diverts power, where it can't transfer power to that device.
We were literally having this conversation about because there was a conversation around, I think something in this category, generically in this category exists, whether it's like form factor appropriate, cost appropriate, all these things to be determined. But that was the exact discussion we were having. I was like, oh, are we reaching a point where we're going to have like, just the generic RJ45 couplers, but where we're going to have like couplers that are like sending power to ground off of a PSE switch to
Hmm.
basically do what you're saying, shunt the power away and feed a
Well, I
guaranteed
just I just
non-powered
texted
cable to an end
our one
device.
of our embedded guys and said, "Hey, you should ask me
I
about
got a
this
product for
later."
you.
Well, I mean there may be a market for something like, especially for like a test bench or something like that too, where it's like you don't know how it's going to behave. Like, it's hard
I
enough to get.
just,
Well, then you
it's
got to
just
take
like I
into
said,
consideration the new PoE plus 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 plus, which is 1.21 gigawatt.
That's right. 88 mile per hour power delivery.
but yeah, I wanted to bring that one up because Mike and I were caught completely flat-footed by this one. And I was like, we were used to the fact that customers would sometimes buy a random like passive PoE brick from the store and plug it into something and smoke it because, there's no intelligence happening or whatever. Like we were used to that sort of warning. We had that stuff like covered in our PoE blog series and everything, but this whole category caught us completely off guard. And I'm like, okay, we got to pay a lot more attention and tell customers you can't just treat this switch like basically assume everything's hot until you confirm otherwise
Well,
because
yeah,
you can
that's
start
kind of what
smoking
you
some
have to
stuff.
do at that
Yeah.
point. So really, then you need to look at best practices, and best practices need to be disable power on non-PoE ports. And even then, that may not be enough. So you need to make sure you're
It
reading
may
the
not be
documentation
enough.
clearly.
Correct. Yeah. Pretty
Wow.
crazy.
Well, that's a pretty big takeaway. I mean,
Yeah, the other reason I wanted to mention it to y'all is because I know how connected y'all are in terms of all the standards bodies and everything like this. I figured y'all may take this back and come back with some more info in a few weeks or whatever,
well,
as
and
far as like
not
what
all
happened
industrial
here.
radios are use PoE. Like, Phoenix radios, you have to hardwire them. But
Oh, interesting. Okay.
right, ProSoft radios can do either. You can either
Okay.
hardwire or PoE. Depending. But even then, they're just standard 802.3 AT. They're 15-volt max.
Hmm.
So there's nothing, no crazy special requirements. But when you start looking at the switching that's coming out now for industrial switching, what you can get now, gone are the days of just the standard 802.3 AT ports, right? Everybody's
Hmm.
at minimum 802.3. Well, I'm sorry, gone are the 802.3 AF because that's the 15
Yeah.
volt, and then everyone's AT or higher, which is 30 volt or 30 watt or higher rather.
Yeah.
Um, you know, so yeah, I mean that's just going to have to be a something that everybody looks out for in general. Well, and then the thing is you're talking, this is more than just industrial switches. This is standard rack mount stuff, right?
I think when I asked
Or is
this
this, or were you
question,
talking specifically about
this is
the
specific about
Fortinet DIN rail?
DINRail. It's
Okay.
and it's not unique to Fortinet. Like I said, we ran through
No, understood,
multiple
understood.
unmanaged PoE switches from multiple vendors that could also smoke that NAT-R and presumably the other 17 devices on this list.
I wonder if it has to do with the fact that it's DC voltage coming into these switches versus AC voltage.
When you look at Matthew's article, he gets into that a little bit, and so it
Does
is
he?
relevant. It is relevant that we're talking about the 52 volts DC and the DC power in the panel and sharing the DC negative between the power feeding the switch and the power maybe feeding the device. If this was a rack mount 120 volt AC switch, this thing's a non-issue.
I'm going to drop that link into our show notes, um,
Yeah,
so
I've
everyone
got the
can
post
check that
about the quick
out.
start guide bullets, and then in those comments, and then I shared it separately in our chat is my colleague, my customer's post about all the Rockwell detail.
Wow,
But
that's
it sort of makes me wonder. I texted a few people that week when I ran into these bullets, sort of asking that general question, like, have you seen this sort of note before? And everybody had the same answer, which was no, but then they all had to like scratch their head moments about like, I wonder, where like there was a story about a device getting smoked and they never got to the bottom of it and they powered it a different way, all these different things. I'm like, I wonder if this has been sort of quietly catching people off guard and letting a lot of smoke out
Well,
in places, you know?
if nothing else, now we've got to at least have, at bare minimum, have this conversation,
Yeah. Yeah.
and then dig into some things.
Yeah, because I'd be curious if you guys are able through your network to find like what when and what. Like did this start with the PoE plus plus standard? Did something change there? Like because I miss I guess what I would say as cranky old man is I miss the old days of not having to worry about this.
Yeah, right. Holy cow.
Because
That's
also these things
insane.
these things we're smoking generally, if we're talking about automation devices, we're not talking about smoking a $50 device, right? We're smoking $1,000 device or a $5,000 device or
Well, yeah, I mean,
Or
on the
an experimental, such and such that you borrowed from a company to test with, and
oh yeah. Yeah.
yeah, it can that stuff can get pretty expensive quickly.
Yeah, for sure.
that's brutal. Um, what all tools are you using out in the field these days, Josh? Just in general.
I'll be honest, we don't push much past our laptops, despite I have been playing with a lot of like test equipment, whether it's from Softing or from NetAlly, not necessarily wireless specific, but just in the terms of like figuring out what test suite's available and is that more effective or faster or easier to use. But I've also messed with that little tool from NetTool. I've been using my,
Was it the NetTool IO? Is that what that
yeah,
is?
have you used that one?
I have not. I've been contemplating on getting one. I've been putting the NetAlly Link Runner 4K through its paces,
Ah, okay.
and it has been pretty impressive on what we've been able to do
Oh,
with it
that's
so
cool.
far.
Loosely wireless related, tangentially wireless related. This is probably my favorite thing in the last 2 years.
Dude, I cannot live without my air console.
I can't believe I didn't know about this for a decade.
Oh, dude,
But
that is one of the most useful things in my kit. I mean, you can get up 30 feet away and just,
how
serial
long
right
have you
into
had one?
everything. Do what?
When did you first find out, or like
I got
how long
mine
have
about
you
a year
had
and a
one?
half ago.
Okay. Yeah, that's around the same timetable as me. But prior to that, I found myself tethered to many a control panel with not nearly a long enough console cable.
I
Uh,
I had a friend of mine who was into that build me
uh,
a 20-foot long
just to be able
DV9
to sit
cable.
down.
And then I had adapters at each end, and it went to a USB adapter on one end, and then it went to a DV9 Cisco rollover cable on the other end.
So the part of the air console I haven't used yet, but have been meaning to, is like, so supposedly the
You
air
can do an Ethernet
console
connection through it,
Ethernet, and then
supposedly.
supposedly like you can get that to like piggyback off your phone for internet to phone home to like a server application they provide for you that you get a license for with your air console. And the whole point of that server application is to basically the same way you would have your secure CRT or pick your console application of choice to basically set up like scripts and things that you can run that you can basically execute them through this app across the air console into whatever you're connected to. And I'm like, oh, that sounds
I
pretty
have
sweet.
not done any of that.
Yeah.
For
I
those,
for me it's
well,
just been about untethering.
this is an audio podcast. The Air Console is a Bluetooth wireless console cable, for those of you who are not
Right.
familiar with it. And it's awesome, and I love mine, and it's rechargeable. My battery lifetime on it, it's probably 10 hours. Um,
Yeah.
I have had several cases where I have used it straight for 6 straight hours, and I was down to half battery on it by the time I was done. Um, the Air Console is awesome. It's straight Bluetooth, which Bluetooth is already a serial communication protocol, and so it's just a minor conversion. And once you have the drivers installed, it's good stuff.
Have you ever connected to anything outside of Cisco or Stratix with it? Like have you used a different
Oh
console
yeah,
connection?
yep,
Okay, cool.
yeah. Aruba switching, Aruba HP
Nice.
switching. Cisco, Stratix, Phoenix, and oh gosh, what was that? Oh my gosh, now I can't remember. Oh, it was Fortinet.
Gotcha. Yeah, that's been my favorite new tool in the last 2 years.
Those are pretty cool. Also, if you have which I don't know if you have one of these, Josh, but you should get one. The WLAN Pi, you can use that as like a
Ah,
wireless console too. But then you also
uh-uh.
have all the stuff you can do with a Pi too. So,
Okay.
like your iPerf server and stuff like that, which you probably already have some similar stuff to that too. But yeah, those are pretty cool. But I try to avoid consoling into anything if I can help it.
Now that link runner, you can put uh juice SSH on it so you can SSH into things if it's on your network, right? But it also there's a test accessory you can get with it that runs as an independent iPerf server, so you can then
Oh,
turn
that's
your
cool.
link runner into iPerf testing, which has been I just got that accessory and it's awesome. And I'm starting to do a lot more throughput testing here in the lab because now it's so easy. I don't have to worry about interpreting data. It's all interpreted for me. And through Link Live, it comes out in a great little format that I can just download and throw into reports.
The other thing I use a ton of is the SIM IPE, which I'm sure you know, Tim Wilborn's. Do you know which one I'm talking about?
I don't.
Okay, I'll put a link in the chat and then I'll tell you what it's designed for and then what I use it for. Okay, so for your controls engineer, automation engineer listeners, all of them have at some point opened the boot P commissioning tool from Rockwell Allen Bradley, and they have all been frustrated by the fact that they're trying to assign an IP to a Rockwell device, and they get to that last step to take it out of boot P mode and put it in static mode after assigning the IP, and it just won't, the setting won't take. And the like official Rockwell documentation for this is like, if it doesn't work, try it again. And so the initial like primary function of this tool is you can assign IPs to Rockwell devices with it, but it will also like you just plug it in, it will just passively listen and you'll start to get across the device like enumerated the list of the devices on the network. And when it's Rockwell stuff in particular, you'll get IP, MAC, firmware, host name, all this good stuff. So a lot of times people will use it just because their first time at a network, they don't know what the IP scheme is. They don't want to guess or guess wrong. They can plug in passively, see with this, see what the IP scheme is, see what's online, that sort of thing. He upgraded it recently to do similar stuff for Siemens as well. But when I first saw this,
For
I mean,
like the
it's
LLDP IP addressing
the,
of devices.
the DCP addressing, I think, on the Siemens
Yeah.
side, you know?
Or
Yeah.
yeah. That's right.
And
Oh
then
boy.
this literally fits in the palm of your hand. And when I first got one, I asked him like, "Hey, you can also make a profile on this thing. Like you can assign an IP to it and you can like ping targets and stuff like that. You can ping out towards targets. But what I wanted to do is like I wanted to ping it because instead of carrying a second laptop I'm trying to like set up routing and VLANs and make sure everything's working. And I'm typically like double laptopping it, going up and down ladders to IDF, whatever it is, like IDF's hanging on columns and stuff. I was like, oh, instead of another laptop, if I could just have this thing. And so on a firmware update, he added that to where I could just literally treat it as a ping target. And I can set up to 10 network profiles on it that I could just toggle between with the up and down arrow key. So it's 1.10 and then I hit up and it's instantly 2.10 and I hit up and it's 3.10 as I'm bouncing it between like VLAN ports on a switch and testing. So there's just a ton of little uses for that thing. So for the price and the size and being battery operated, it's just been that thing's the most like beloved tool I've ever seen on LinkedIn in terms of the amount of automation engineers that have just praised it just for the boot P part of it, just for like assigning IPs. Like everyone's like, oh, thankfully I don't have to use this garbage piece of
Well,
software anymore.
well, I'm not, I can't, I'm not going to, no comment. But we get Siemens devices sometimes and, the bag gets heavy and they're, Proneta and Sonic P and I, and it
Oh
used to
yeah.
be, I forget what the other one they used to have. But it only runs on Windows and
Oh
It's a
yeah.
very, it's a very German thing of, well, you should have, the field PG is a PC.
Oh yeah.
And we run, pretty much most of our people run on MacBooks. So it's like, okay, I've got to
Ah,
carry an
okay.
extra laptop to do this because then you get in VM hell and you're like,
Yeah.
do I bridge the adapter and then do
Yeah,
this? And
yeah.
or carry a second laptop. So if I had a money sound effect on a soundboard, you'd be hearing me check out with one of those right now. But that's awesome because it's like, you know, um, I think probably a lot of enterprise people are kind of used to, hey, let's import this big list of MAC addresses and pre-stage it, and then you just plug them up and it deploys all that stuff. But like a lot of our stuff, it's like, hey man, you got 100 devices and you have to physically plug into each one and manually assign that stuff, or
Yeah, that job I mentioned with
semi-manually.
the 1250 VFDs, I saw somebody like fighting the software, and then I told the integration manager on that job because this is like a $1.4 billion CapEx job. There was like several hundred engineers on site for 18 months, and I was like, "Yo, is this the plan for 1250 VFDs?" He's like, "Yeah." I was like, "Why?" And I had one with me. I was like, "Have him use this," and he starts using it, and he's like, "Boss, can we get like 20 of these things?" And so they ordered like 20 of those. And they did all the drives that way because it was just a million times faster and more reliable.
God, that
We did
many VFDs, that's crazy. That had to have been one chatty network right
for a
there. That
guest
many
spot.
VFDs.
Not just that many VFDs, but VFDs on DLR rings and on DLR rings on M12, like M12 connectors, like field terminated M12s.
Ugh.
So you can imagine that the physical media situation wasn't always consistent.
Gotta love a good X-coded M12. Well, Josh, before we head out for the day, why don't you give us a quick overview of Traceroute Con and what that is and
Ah.
what that can mean for people?
Yeah, so TraceRouteCon, I have taught some version of a 2-day industrial Ethernet class for 17 years now. And as Traceroute specifically, we're just past year 8, and we would do 2-day industrial Ethernet training for end users or integrators like at their facility. So I'd fly out and train a group of 10, 12, 20, 75, whatever. And I was posting about it on LinkedIn, like, hey, we were here this week doing this training. And in probably late 23, we just been getting so many individual messages from just like one guy, one gal saying like, "Hey, can I get this training?" And I was like, "Man, how do I address this? Like all these individuals that are interested in this training, it doesn't make sense to fly out to do one-on-one training." And so eventually we got that message so many times. I was like, "I wonder if I hosted in Dallas a training, could I fill up a room? Could I put 10, 15 people in a room?" And I basically put it out there to some of the people that had messaged saying like, and eventually I was like, okay, I can't crowdsource a date. I'm just gonna throw a date out. I'm gonna get one person committed. We're gonna do it. I'm doing it if it's one person or if it's 5 people, but we'll see what happens. And so in February 24, we held what was deemed the first Traceroute Con, which is our 2-day industrial networking training, but sort of in a small conference format. We do it at this nature preserve over here just outside of Dallas. And we take everybody out for barbecue. We feed everybody well for 2 days on site, and we also take everybody out for barbecue on that first night. And so you get to come learn. If you're looking to improve your industrial networking chops, you can come do it with additional automation professionals from different verticals, while they're learning the same thing. That it's typically, I would say, on average, like 70% automation, and then the last 30 is a mix of IT that wants to understand OT better and cyber, whether it's IT cyber that's been tasked with securing OT or OT cyber teams. And there's generally about 35 to 40 people in the room. So we did one in February 24. We did another one in September of 24. We just did one in September of 25. We're probably going to do the same thing. I don't have an exact date yet, but probably around that September timeframe. And I'll get you a link for the show notes that they can sign up to just get notified as soon
That
as
would
we
be
have a
great.
date.
What's been the growth? Has it been exponential from the first one that
We
you did?
So I intentionally, because I love the facility so much, I just that room holds about 40. So I hold it in that same room because at the event we've got this training room for 40. We've got a space for everyone to kind of get out of the room and eat and also kind of go outside if the weather's nice, which we've been lucky the first couple of times. And then we also have I got a bunch of vendor sponsors that help out with the event, and we have a small like sponsor showroom where it's literally like I work with the vendors to sort of highlight, put some gear on the table and sort of highlight different pieces of gear from different vendors and like why do I even have this relationship with this vendor? What do I think? What is the unique thing that they have that somebody else doesn't have? There's literally little signs on the table with Apple Memoji Josh with a quote about what I think is cool about the gear that's on this section of the table or whatever. So we've done that 35 to 40 3 times in a row, and I have no intent on changing it right now. I just keep running it at that same cycle. We have been asked about running more than one a year again. All I can say for now is that for 2026, I don't have any plans for that. Just I plan on seeing another group of 35 to 40 in September.
Well, definitely keep us posted. We want to make sure we get it announced and out there.
Will do.
And this is the industrial Wi-Fi shop, so I think we might have to try to get some wireless integrated into your OT conference.
Yeah, true, true.
Well, Josh, man, I can't thank you enough for taking the time and coming hanging out. We've actually covered a lot of material today, and I really appreciate it. Jeremy, do you have anything else?
No, I this was very enjoyable. That's about all I've got.
Thanks for having me on, guys. I really appreciate it.
No, totally, man. And with any luck, we can get you back, and we'll discuss some more behind the scenes of what it takes to support industrial wireless from an OT network perspective. Thanks for listening, everybody, and we hope you join us on our next episode of the Industrial Wi-Fi Shop.